Hey guys, welcome to Unit 6 Notes C. Now that we know how to construct balance equations, we're going to see how important they really are. We're going to learn something called stoichiometry today. So stoichiometry is very similar to dimensional analysis. We're going to be going through conversion factors, but we're going to have a new conversion factor that comes from our balanced chemical equations. So now we're going to call this stoichiometry anytime you have our new conversion factor, which is going to be known as the mole ratio. So our mole ratio is going to come from a balanced equation. So if I give you an equation like this one, where aluminum reacts with oxygen, forming aluminum oxide, is this already balanced? No. So we would need to add only coefficients. Remember, you can't change the subscripts. So when we balance this equation, what does this really tell us? We could read this as needing 4 aluminum atoms to react with 3 oxygen molecules to form 2 aluminum oxide formula units. So it's telling me a relative amount of how much stuff reacts with how much other stuff in order to form how much of the new stuff. Sounds very generic, right? How much stuff relative to another amount. So what unit would we use for that, of course? Moles. So we can say 4 aluminum moles is proportional to 3 moles of oxygen, or you could do 2 to 3 or 4 to 2. Any coefficients can be set relative to each other when you use the moles from the balanced equation. So when you do put those coefficients on your formulas, it tells you the amount or moles of the substance, and then we can use those as ratios in order to work a new type of problem in stoichiometry. So the mole ratios are our new conversion factor, and those numbers always come from the coefficients of the balanced equation. It has to be balanced. The kind of problem that I see sometimes is an overextension of this, trying to use the coefficients now in places where they don't belong. Remember that 1 mole is what was equal to 22.4 liters, or Avogadro's number of particles, or the molar mass. All of those 3 things are all equal to 1 moles. Those are the conversions that we were doing in our last unit, Unit 5. We're still going to use those conversion factors, but this time we're going to use another conversion factor also. That doesn't change the original conversion factors. It means we're going to bring in another one, which will be a separate conversion factor. So keep in mind it's always still equal to 1 mole if you're using the conversions from Unit 5. That will never change. All right, so let's look at a problem. And the very first thing you want to do in stoichiometry is construct a balanced equation. So let's look at this reaction. Iron 3 oxide reacts with carbon monoxide to form iron and carbon dioxide. So what would be the formula for iron 3 oxide? Iron plus 3 and oxygen has a minus 2. So when you crisscross that, the formula would be Fe2O3, also known as rust. We're going to react that with the carbon monoxide, mono meaning 1 oxygen, in order to form iron, which is not diatomic, and so we'll leave it alone. And then also forming carbon dioxide, di meaning 2. So here I've translated my equation into formulas. The next thing that I need to do is balance it. So what would be this balanced equation? We need to add our coefficients. So with coefficients, we can construct a balanced equation. Now we're ready to look at one of the math problems. So this question asks how much carbon monoxide, one of our reactants, is required to react with 25 particles of Fe2O3. So it's asking if it takes 3 times more carbon monoxide than it does iron 3 oxide, then how much of that would that be? We can actually set this up with our mole ratio. So 25 particles, 25 pieces of Fe2O3. Generically speaking, I'm just going to call that a mole. So if I have 25 amounts of iron oxide, I can now put my moles of Fe2O3 on the bottom. This should seem a little familiar. Whatever we start with, those units go directly on the bottom. And then what do I want to go to? I'm being asked about how much CO2. So again, when you're just generally comparing amounts of one thing to amounts of another thing, we're talking moles here. But this is going to be moles of carbon monoxide. Okay, so now where do the numbers come from whenever you have mole versus mole? mole versus mole of two different substances, this is our new mole ratio. And the mole ratio numbers always come from the coefficients of the balanced equation. So for carbon monoxide, the coefficient is 3. For the iron 3 oxide, when there's not a coefficient, we would know that to be 1. So I'm going to set that proportional to 1 mole. So what is 25 times 3? Of course, 75. And that's how much, so we'll just stick with moles, carbon monoxide would form. Or you could say that is a molecule, 25 molecules of carbon dioxide. Just think about this without the math. If one Fe2O3 reacts with 3 carbon monoxides, and I got 25 of this guy, I would need 3 times as many of that guy. So if this is 25, that has to be 75. The math is going to get much harder, so I want you to get used to showing your work out like this. If we're starting with Fe2O3, then we've got to put Fe2O3 on the bottom and then convert to the carbon monoxide. So this is our first way to use the mole ratio. All right, so let's look at some harder problems here. Ones that have other conversion factors as well. Okay, so we had our 25 times 3 to be 75 carbon monoxide particles. All right, let's bring mass into this. So same balanced equation for all of these. Now we want to know what the mass of carbon monoxide would be, starting with a mass of the iron 3 oxide. Can you convert grams of one substance directly into grams of another substance? Of course not. The only way that you can convert two different substances is using moles. So our general plan here is to convert from grams of iron oxide into moles of iron oxide, switch that over to moles of the carbon monoxide, and then convert that back to grams in order to answer our mass. So this is actually going to require 3 separate conversion factors. We're going to start from the very beginning. I want to start with the given 146 grams of Fe2O3. I'm going to put that over 1. Notice that I'm writing the formula of the substance. Since we're changing substances throughout the process, it's really important that you have not just gram or mole, but also of what. So we want to make sure that all of this is considered part of the unit now. So I'm going to put all of that into the denominator of my next conversion factor. Grams of Fe2O3. Now I know I can't compare gram to gram, so the first thing I'm going to do is convert to moles. But this is going to be a molar mass, so I can only convert directly to moles of that exact same thing. So I'm going to have moles of Fe2O3. I can't change the substance. I can't change out of iron oxide until I'm in my mole ratio. So let's go there next. Mole of Fe2O3 is on the top, so I'm going to put mole of Fe2O3 on the bottom. This dimensional analysis skill is the only way to tell which way your mole ratio should be flipped. Now that I'm in moles of one substance, I can now convert to moles of another substance. So I'm going to stick with moles, but now my other substance. And so what were we trying to find? The mass of carbon monoxide. But I can't go to grams yet. It has to be mole to mole. But now I at least know what my substance is. So I've got my moles of CO. Problem is, it asked for mass. So I'm going to get rid of the moles, again by putting it on the bottom. Mole of CO. And now I can convert to grams of CO. Okay. Now when I go to put in numbers, I want to first identify my mole ratio. So your mole ratio will be the only one which has mole in 2 places. That has 2 moles. Mole to mole, a ratio of moles, right? That conversion factor and that conversion factor only will come from the balanced equation. So what was my coefficient for the CO? A 3. And what is my coefficient for the Fe2O3? Just 1. That is the only place you can have a number other than 1 for moles. outside of that mole ratio, I'm going to go ahead and plug in 1 mole because I know 1 mole was equal to your molar mass, 22.4 liters at STP, or your Avogadro's number of particles. So whatever I'm equal to a mole here, it'll be 1 mole. It's only in the mole ratio. Just because there's 3 carbon monoxides, I'm not going to double the molar mass here. I've already got that taken care of right here. So we wouldn't want to do that twice. So this is still the molar mass of just 1 carbon monoxide, and this is the molar mass of just 1 Fe2O3, no matter what the coefficients are, because the coefficients only go here. So now let's go ahead and get into the molar masses so we can plug in some numbers here. So I want to calculate my molar mass of the Fe2O3. So I'm going to take my iron, which is 55.85, and have that twice, and then I've got my oxygen, 16 even, 3 times. And so I'm going to add all that up and plug in for the molar mass of the iron 3 oxide. Then for my carbon monoxide, my carbon is 12.01 and my oxygen's a 16 even. So I'm going to add all that up and plug that in for the carbon monoxide. So then that will allow me to get my molar masses plugged in, and I would have all of my numbers set up here. So before I go into actually solving the math, I want to point out a couple things. With the units, the unit gram and the substance have to be exactly the same to cancel. Gram and iron oxide. So yes, they cancel. The other thing is, notice when I convert gram to mole, I have the same substance. If I'm converting substance, it has to both be in mole. So you can think of this as only being able to change one part of the unit at a time. So here I've changed gram to mole, but kept my Fe2O3. That entire thing is exactly the same down here, so it'll cancel. Here I've kept mole to mole so I can change my substance. Now I have moles of carbon monoxide, which is exactly the same, moles of carbon monoxide, so I can cancel my unit again. And since I'm keeping carbon monoxide the same, I can go from mole to gram. So that's how the units kind of work out, and in the end, I will get grams of carbon monoxide. Now we want to make sure that that is what we were looking for, and all of the other units completely 100% cancel out. Grams of carbon monoxide will give me the mass of carbon monoxide, which is what I was looking for, so I know I've set this up correctly. Now I want to put it into the calculator. 146 divided by our molar mass times 3 and times the molar mass of carbon monoxide. Let's see what we get. So our molar mass of the iron 3 oxide turned out to be 159.60, and then we would have got 28.01 for our molar mass of carbon monoxide, and then final answer, 76.8 grams of carbon monoxide. Notice I started with 3 sig figs, and so my final answer also has 3 sig figs, 76.8 grams of carbon monoxide. Let's try one more. Again, same exact equation, so it saves us from having to do that again. This time we're going to start with 8.65 grams of carbon dioxide. So the given will go first. Notice this is of carbon dioxide, which is one of our products. So we're dealing with a different substance this time. So I'm going to go ahead and put this over 1. Next thing I would do, since I have grams of carbon dioxide on top, we're going to put grams of carbon dioxide on the bottom. We want it to cancel. And we know we can't keep it in grams, so the very next thing we would do is go to moles. But I can't change the substance if I've changed the unit, so it's still CO2. Once I get to moles of the substance, now I can change it into something else. So let's go ahead and set up what we know will be true for the next conversion factor, bringing moles of CO2 to the bottom. And now's the tough part. What should I put on top? What do I want to change CO2 into? The question here is asking for the mass of iron 3 oxide. So that's going to tell me the substance, but be careful because you can't immediately go to mass. You can only go mole to mole if you're going to change the substance. So the substance this time would be the Fe2O3. And since I know I want mass and not moles, I'm going to go ahead and bring the moles of Fe2O3 to the bottom. And then now that I have Fe2O3, I can change from moles to grams. Grams of Fe2O3. I would advise setting up your mole map, your unit map, before you start to plug in numbers, and then kind of take a step back and think, what numbers should I plug in first? And I would go with your mole ratio first, so you don't accidentally put it somewhere else. Identify where it is that you're going from mole to mole. The mole ratio numbers always, always, always come from balanced equation. So again, we want to find our coefficient for the Fe2O3, which is 1. And now I have moles of CO2 over here, which is 3. But notice how this time the 3 is on the bottom, and we have our 1 iron oxide on top. That's because we were coming from carbon dioxide. So you got to use that as dimensional analysis skills in order to figure out which way your mole ratio goes, so you don't put it upside down. Once you've got that figured out, you go and you steal your coefficients and your mole ratio is all set up. Once you've figured out that mole ratio, you're going to want to go ahead and put your 1 moles in your other conversion factors. Those are always 1 mole. You're not changing anything from the unit 5 conversion factor, you're just adding in a new one. So now that we have grams, we know 1 mole is equal to our molar mass. So here we need to find the molar mass. And from the last question, we already know this molar mass was 159.60. Now we need to find the molar mass of carbon dioxide, which will be a little different than carbon monoxide because it has that extra oxygen. So here you're finding 12.01 and 16 times 2 for your carbon and your 2 oxygens to plug in for your molar mass here. And then you should be ready to solve the problem. Before you type anything in the calculator, check your units. Grams of carbon dioxide, grams of carbon dioxide. Let me use a different color here, sorry. Grams of carbon dioxide and grams of carbon dioxide. If both are the same, it cancels. Mole CO2, cancels. Mole iron oxide, cancels. Gram of iron oxide doesn't cancel. So that'll be the units for the final answer. Is that what we wanted? Is that what it asked for? Mass of iron oxide, grams of iron oxide. It matches, so we know we have it set up right. Now it's just a battle between you and the calculator. We're going to get this all in one step at a time and see what our final answer is. So go ahead and start punching that in. All right, so we should have gotten 44 for our mass of carbon dioxide, and then we have the 159 for our mass of the iron oxide. And then when you actually do this entire conversion in your calculator, we get a final answer of 10.5 grams of Fe2O3. Check your sig figs, 3 to start with, 3 in the end. It only depends on the given, so we want to make sure we round to 10.5. And that'll be our final answer for our last question. So practice stoichiometry, practice makes perfect. You want to basically go from gram to mole, convert your substance, and then mole to gram. By the way, you can also do this as going liters to mole, mole to liters, or even gram to liters, gram to mole, mole to liters. You can mix up and use different conversion factors here outside of the mole ratio. You would just need to be using 22.4 liters or Avogadro's number of particles, or the molar mass. You take whatever you're given, convert it into moles, use our new step of the mole ratio, and then you can convert back to whatever it asks you for. So this is a very versatile process. All right, guys, that's going to finish up the notes for Unit 6, Note C. The next set of notes you're looking for Unit 6 will be Notes D, where we're going to be doing a lot of the same conversion factors in order to identify something called a limiting reagent and to determine the percent yield, or how much product is made from a chemical reaction. And that'll finish up notes for Unit 6. So we'll see you there.